A very pleasant good morning to all and welcome to 5 days faculty development program on innovative research and development trends in electronics and communication engineering organized by Department of Electronics and Communication Engineering GL Bajaj Institute of Technology and Management. This program is technically co-sponsored by IEEE UP section, AKTU, IIC, and Start in UP, a government initiative. I, Dr. Asta Sharma, on behalf of EC Department, welcomes Galaxy of Intellectuals, Your Excellency, Chief Guest of the Day, respected HOD Sir, Director Sir, HODs of other department, faculty members, and dear participants. We are very grateful to have with us today for the session Dr. Satyakesh Dubey, and the agenda of today's talk is antenna design MIMO systems. Before that, we welcome and listen the enlightening talk of our today's chief guest of the day. I would like to give a short presentation of the department so that we all know about each other better. So just sharing my screen. Is my screen visible?
Yes.
Okay. So before introducing the department, I would like to introduce the institute. GL Bajaj Institute of Technology and Management, Greater Noida, is one of the prestigious institutions under the GL Bajaj Group of Institutions. It is one of Uttar Pradesh best engineering and management colleges and is known for providing its students quality education and great placement opportunities. This institute is approved by AICT, MHRD, Government of India, and is affiliated to AKTU University. The Department of ECE visions to become a department of repute and prepare globally competent and socially responsible professionals with holistic knowledge and technical skills. Under the mentorship of Dr. Satendra Sharma, HOD, Department of Electronics and Communication Engineering. The department is NBA accredited and offers undergraduate course which is approved by AICT. The department has always exerted best of its efforts to meet the objective of achieving technical excellence in areas of electronics and communication engineering. These are some of the highlights of the department. The department has been established in year 2005, right at the inception of the institute. The department has observed and has witnessed the growing seats from 60 seats to 180 seats. We are also proud that we are delivering #1 result in Uttar Pradesh under the affiliation of AKTU University. This currently 2021 batch also, we have provided the highest rank in the first semester results. The research credentials of EC departments are as follows. We have here with us 5 research groups. 20 plus patents have been filed and published. Our students have been awarded or granted approximately 15 lakhs grant. We have here with us 11 laboratories, 6 advanced laboratories, and approximately 300 plus research articles. Also, our department, it focuses on 360-degree student development encompassing of all the elements starting from state-of-the-art laboratories, highly qualified faculty. We also are annually organizing international conference, MedCom, and this year only our conference is nearby, that is in October, and we are getting huge participation of papers. We also organize international webinars, FDPs, SDTPs, workshops. And for students, we also take them to industrial visits, internships, workshops, and trainings. We provide 100% placements and alumni interactions. We also focus on extracurricular activities for the students, that is Anvita Club and Tech Blitz are here in the department. And we invite renowned people from academics and industries for guest lectures. We are also having at our department NPTEL local chapter, ICEIT GL Bajaj student chapter, IEEE GL Bajaj student chapter, And we are also having department newsletter as well as journal. These are some of the best brains to mentor the bright minds, the complete faculties which are here at the department, and it is a very great team we are having here. These are the additional facilities, lab facilities to make our students industry ready. Cisco Networking Academy, Technology Incubation and Development Center, Center of Excellences in Biomedical Image and Signal Processing, SDR and MIMO systems, Research and Development Lab, CNC-based PCB routing. These are some glimpses of a student's achievement, where one of our student, Kajal Srivastava, her project was selected amongst the pan-India and only amongst the 5 projects to be showcased in front of Prime Minister Shri Narendra Modi and the Prime Minister of Israel, Mr. Benjamin Netanyahu. And also students are participating and bagging prizes in various platforms like Anveshna Delhi NCR 2021. Also, they have won awards in Startup Awards and have received fund of approximately rupees 10 lakhs through Atal Incubation Center and NXG Venture. They have also bagged prizes in Divisional Innovation Exhibition and also Technovation Hackathon. And not only the students are participating in the competitions, but they are representing as delegates on various global platforms like Women Economic Forum. And our department has signed MOU with ALTTC BSNL Ghaziabad. The current batch, we are very proud that we have witnessed record-breaking placement of 92%, where the highest package has been of 18.2 lakhs awarded to the one of a student, and the top recruiters being Cisco, Bosch, Ericsson, Accenture, Cognizant, and many more. Our students are also establishing successful ventures and are emerging as budding entrepreneurs. So we are happy that we have such creative minds with us. We have also organized webinars successfully, and the participation has not only from national front but also international front. And we are actively engaged in organizing such kind of sessions to for faculty as well as for student development. These are some of the industrial visits where we take our students to leading the organizations like ST Microelectronics, Electronica India, ALTTC Ghaziabad, Uniconverge Technologies, Ministry of Electronics and Information Technology. And these are some of our notable alumni which are serving in reputed places like Indian Army, Indian Air Force, and ISRO, Ministry of Defense, and are also spread all over the globe. And we are proud to have them in GLB family. So this is all about us. And if you want to reach us, please contact at the given email address. So I will stop here my presentation. Okay. So now I would request Dr. Kirti ma'am to please introduce a speaker for today.
Sure, ma'am. Good morning, one and all. Am I audible to all of you?
Yes, ma'am.
Good morning, one and all. Myself, Dr. Kirti, and I am very glad to introduce our eminent speaker of the morning session, Mr. Satyakesh Dubey. He has received his PhD in 2010 in engineering from Allahabad University. Currently, he is scientist in microwave standards, National Physical Laboratory, New Delhi. His research interests continued to be in the precision microwave measurements for specific absorption rate, radiated power density, attenuation, and S parameters, along with EM wave analysis for nanoparticles. He is also working in a new atom photon interaction based novel technique for accurate and precise E field measurement. He has authored over 20 international peer reviewed journals and one Springer book in electrical and computer engineering on LabVIEW based automation guide for microwave measurements. He was with National Institute of Technology, Raipur as lecturer, Institute of Plasma Research, Gandhinagar as PDF, CSIR, National Aerospace Laboratories at Bengaluru as QHF Scientist Fellow. Since 2012, He has been with CSIR National Physical Laboratory, Delhi, and is working on laboratory mandate of developing and maintaining of primary standard for microwave measurements. He has supervised one PhD student and four PhD enrolled now, 17 MTech students and 15 undergraduate students. He has delivered more than 40 invited talks on EM wave propagation and its application. Now, I would request our head of the department to welcome our speaker. Over to you, sir.
Thank you, ma'am. Respected guest of the day, Dr. Satyakesh Dubey, sir. Various participants from different corner of this country, all faculty members, staff, HODs, very good morning and welcome to this juncture. On behalf of management and staff of GLV, I welcome you, sir, at this platform. I know Dr. Satyakesh Dubey, sir, he is very renowned scientist in the field of microwave, and his total life is based on practical. If you get one sentence from him, if you can catch, you can become one researcher. So if you observe keenly his presentation, you can be a best researcher. So I request Dr. Satyakesh Dubey, sir, to start your speech so that we should be enriched in technology. And once again, I am very much thankful to you, sir, that you are from such a reputed organization in busy schedule. You have spare time for us, and we are very much thankful to you, sir. Thanks a lot. Thank you very much, sir.
Thank you, Astha Sarma ji, for the invitation to be the part of this faculty development program. I generally used to say no for this type of program due to the schedule for which Sarma ji is talking. But as I have promised Sarma ji in my last talk, which you have seen on your screen, 5G and beyond, that I will definitely talk something in your faculty development program. So I have to be agreed on that. It is a very tough week for me. I could not sleep in the night due to some personal reasons. I have to receive some relative from railway station and all. So things are not very good, but that is not the case. I am thankful to Satyen Sarma ji.
Thank you, sir. Thank you very much. Aapne spare kiya.
I am thankful to Satyen Sarma ji who asked me to be here and speak on MIMO. I am also thankful to Kirti Kaushal who gave a introduction about me. I am just willing to tell you people that I am, as sir has told, I am a 37-year-old guy who did few things early in his life. That's it. ठीक है, बाकी जो चीजें हैं मैं अपने प्रेजेंटेशन में बोलूंगा आपसे. But my intention to you people are, it is nothing extraordinary. You have to be very focused. And at one point I am agree with Sarma ji that I am a person who will talk in the term of practical. You may find few things which you have never heard of, and I will try to give you a faculty-wise glimpse. I have seen so many people are here from various different arenas, like some are from South. I have seen the name like Arun is there, Hemavati is there. Some people is there from one Joshi ji is there, one Kundu ji is there. It means it is a mixed audience, and I will try to address Salja C is there. So it is a mixed audience. I try to be in English. As I told you, I am from UP, so I may be in Hindi. If you feel awkward, let me know in the message where Tripurari Saranji just typed good morning to all. So the same you can do.
Good morning, sir.
The same you can do.
Sir is always prompt and daily he is in time. Tripurari Saran, sir, I am very much thankful to you.
Thanks, sir. Thanks.
You can. Good morning. So with this, very warm welcome to you all on the occasion of Ganesh Chaturthi. I give my best wishes to you people, and I want to take name of Ganesha to start this talk on MIMO because he is the God who go by brain.
Yes.
He is the God who don't run. When everybody is running around the universe, he find the easiest way. So MIMO is like that only. We will discuss in more detail. So let me share my presentation in the screen. and
Yes,
then
sir.
we will
Yes,
start.
sir.
Okay.
Thank you, sir. Thank you, sir.
Is my screen visible to you all
Not yet, sir.
now?
No, sir. Okay, now it's started presenting. Yes, sir. Now it's there.
So
Sir, request to put it in full screen mode. I think so. You have not shared entire screen. So
no, madam. Okay, wait. I will repeat it. No problem. Is it okay, madam? Now it is there.
yes, sir.
Now it
Yes,
is
sir.
full screen
Yes,
mode.
and you can press on hide button because there
Yes,
is no
that I
content.
will. That I will. So I am here to discuss about the MIMO system, especially about the antenna design. Before we go, I just want to start with this African proverb. If you want to go fast, go alone. If you want to go far, go together. This MIMO is just to connect you through all kind of ways, whether you want it or not. That we have to discuss in next 1.5 hour. I am not a faculty, so it is very difficult for me to speak for 2 hours, but I will try to speak. I have prepared presentation in that way only. But so before going to that, let me introduce myself. As of now, I am principal scientist. You can consider it as scientist E, and I am heading after electromagnetic metrology. That is when and I belongs from National Physical Laboratory, which is the National Measurement Institute of India. When I'm saying that it is the National Measurement Institute of India, it means all the measurements which is being carried out throughout the country have to have a traceability chain associated with National Physical Laboratory. Let me explain you in a very crude way. Suppose you are procuring a potato from a shop. If it is 2 gram less or more, it is not a matter to be discussed. आप कहें ठीक है चलता है कोई बात नहीं. But if you are procuring gold, can you bargain with 2 gram? No, you cannot. It means the weight is important, and that weight have to be in case of gold. It should be a BIS hallmark, and that BIS hallmark have a measurement traceability from NPL India. That's why we are National Measurement Issue. Similarly, you people have seen that if fuel persons are doing adulteration or doing wrong measurements, they are having their regional inspectors. Those inspectors have their instrument traceability to us. So we are looking after the country's measurement, and we maintain standards, we provide traceability and disseminate through its product certification. So when we talk about the MIMO, we have to think in a term which was invented in 1994. Even in concept it was there for 79 or 80s also, but it took almost 20 years to be a standard where it can be used, especially in 3G system. That we will discuss, and we have to see this in the term of interconnectivity. And when you are doing interconnectivity, how you could be linked yourself with respect to minimum loss of data or information interference. That is all about the MIMO system. In my presentation, let's begin with this motivation. I find it on yesterday my WhatsApp. This guy is the central bank governor for Afghanistan. They appointed just now. But in spite of having that gun, this guy is also having a laptop. It means he knows that though they can win this country by gun, he cannot run his economy by gun. He have to come to the technology, and that technology will bring money, prosperity to their nation, or their thought of idea to be processed. Whether it is good or bad, that is a matter of debate. We are not in that debate. We are in the process that this guy who is a firm believer of violence, have also to be believed in this Dell system, this HP printer, and their interconnectivity. The important part is that it is connected via LAN. You can see there are two wires going on, and these two wires are the LAN connection, so that this guy could access this one with respect to the data. So we have motivation. If a extremist or a terrorist institution understand what is the meaning of technology, then we should definitely understand. So I am going to discuss about the MIMO, the overview of mobile networks, what are the MIMO communications, single user MIMO, measurement of antenna system, measurement of MIMO, its application, and one simulation example I have considered for you people so that we could discuss this in more detail. So let's come to the future wireless network. The image which is shown here, it is taken from the university's website page, and you can consider it as an image from Google, where the reference is not mentioned. Otherwise, I try to mention the reference from where I have taken the images. Okay. So here you can see a futuristic wireless network is being proposed, where Internet of Things is capable to connect each and every electronic gadget with respect to them, and then try to link that in your day-to-day life. It means either you are talking about the smart homes, or you are talking about the space, or you are talking about the autonomous cars, smart cities, or body area network, or any kind of device. As of now, people are trying to get Apple watches. Why? Because it is capable to give your blood pressure data, your heart pulse rate, your sleeping order, your sleeping intensity, your stress data on your mobile, even how much step you have taken, how much calorie you have burned, that is earlier available. But these type of calculations, they are now capable to do and provide you in the real-time access. So a lot of lower quality, I don't say cheap, lower quality gadgets are available with respect to the domain, and it is costing around 3,000, 4,000, and they are having the same kind of facility. The only part they don't have is about their repeatability of data. It means you cannot rely on those data. So why we cannot rely on those data, that we will discuss in when we were discussing the measurement part of the MIMO. That we will discuss at that time. But key part is कि सब कुछ जुड़ने वाला है. Each and everything is going to be connected, and once they are going to be connected, what problem we are going to face and what are the solutions we are having, that leads toward the MIMO. So let's talk in a one or two specific application way. जैसे आप autonomous cars देख रहे हैं. It is not yet started, but now people have seen the videos on WhatsApp and social media that now automated parking facilities are being enabled, or advanced cars like Creta or even any other SUV or high-end car which is costing more than 15 lakh. They are having the perfect parking sensor with 3D modeling. That your car is going to be lying in this direction with this speed, so it is going to be stand like this. That kind of car parking assistance is being enabled to the car with the help of communication associated with automotive radars fixed on the all four directions of the car, so that they could access they could image all four directions, get those data validated by IR sensors, and try to give you a 3D mapping associated with your measurement. This is a very important task to let you know that how much data is going to be available, and analyzing those data is how much important. Without interference or without noise, that is a big challenge job. That's what we can understand from there. Likewise, you can see this is a tower, a ATC tower. At a time, it is having so many interconnectivities with respect to that one. And now just consider one more thing which is not picturized here, that drones are moving and ATC have their control. And just consider that only a food delivery company get access to deliver your food using drone. वो आइडिया वाला आपको यूनिवर्सिटी वाला ऐड याद होगा ना, आइडिया यूनिवर्सिटी का आइडिया मोबाइल कंपनी का ऐप था कि द गाय स्टडीज दीस थिंग्स ऑन आइडिया. So suppose that thing happen and only 1,000 people order something which have to be delivered by drone, then what will happen to ATC? Because ATC have to have their EMI data, they should have their position tracking, they should have all kind of interconnectivity with respect to their radars. Then only they can monitor the situation to save us from any kind of mishappening or mishandling. So for that, just realize the situation when each and everything is going to be connected, how much we will be exposed to the word for good or bad thing, what I have given you as a motivation. तो अगर आपको अच्छा रहना है, तो then you have to be very connected and very securely connected, not only connected, securely connected, or speed is the time demand, you cannot deny for that. So it means it is going to be a huge communication among people and devices that you cannot control and you should not try to control. So what challenges we are going to see if these type of situation happen? Either it will be in the short range, or it will be in the long range, or it will be in the long-term evaluation, or it is in the ad hoc, or it is in the Wi-Fi, or it is in the spectrum sharing. Whatever it is, we are going to face the challenges. First one is the GBPS data transfer rate with no errors. When I am saying no error, it means there should be no possibility of call drop. There should be no possibility. As की date में when you make a WhatsApp call, WhatsApp used to ask you a feedback on daily, you are satisfied with your WhatsApp call or not. Same thing happened with when you are using the Google Duo. You are satisfied with the audio, you are satisfied with the video, because they are knowing that they are not capable to provide you the quality which they promised, or the quality which should available to you when you are making a video call. So it means there is a requirement related to GBPS data transfer rate with no errors. It should be an energy efficient system, because if you are transmitting a huge amount of data, receiving them in a particular manner, then it should be, if we are capable to do, it should be a bifurcated spectrum, it should be a reliable, and it should have a coverage also. Coverage means when we are talking about the reliability, it means whatever is being transmitted, that should be ensured to the last mile delivery where the end user exists. And when we are talking about the coverage, it should be penetrate more and more other than the existing system, so that I will give you 1-2 examples associated with this one when I am talking in the term of examples, then we will go by that. And not a homogeneous network, it is now heterogeneous. Now people are using radio over fiber, people are using Wi-Fi, people are using mobile data, people are using some other short range communication. So people want all these things to be interconnected so that they can access each and everything. Mobile makes these possibility possible, and inter-network connectivity, what I am talking you, inter-network means now it is not available. Only few things we are capable to see. When the starting phase of Jio came into in India, they give you a VoLTE option, voice over long-term evolution. It means you can make a voice call over a Wi-Fi connectivity. That's what they are claiming, or a long-term evolution system. So they make a app for 3G phones, especially not 3.5. I should not say 3G, 3.5G phones, which are having some kind of array mechanism, and that they are doing. So अब जरा डिवाइस की तरफ देखिए, उसमें क्या स्थिति है. एक आपको बीटी चाहिए, एक सेलुलर, you needed a cellular phone, you needed a memory, you needed a Wi-Fi, you needed a millimeter wave system, you needed a cognitive radio, you needed a radio system, you needed a GPS receiver. These much devices to be inbuilt in your phone when we are talking about the 5G network or advanced. If it is so, how much small it could be? And then what will be the performance of battery? If you go to the higher frequency, what will happen to their data penetration or the coverage? If you are using the multi-radio integration, what will happen to the other signal? What is the possibility to be in coexistence for the radio as well as the millimeter wave, or the mobile communication or cellular communication as well as GPS? So these are the challenges where we have to be prepare ourselves. And this is an example where simply a software defined radio, if you use to talk, it will have a lot of analog to digital converters, which will have a wideband antennas for them and a span bandwidth of desired signal. So you needed to be specialized in this job with respect to टू पैरामीटर. पहला तो ये है कि आपको डाटा भेजना है, और दूसरा ये है कि आपको ये जो डाटा भेजना है, you should be very accurate. But first one, you needed it is a US data taken from this FCC. What they are saying that their total spectrum is full. If it is 400 megahertz, which was sufficient in 2009, now it is minus 275. They don't have any kind of spectrum with respect to data. This is mobile tariff in India. In a billion per month data, which we are packets billion per month data, which we are using, just see the demand and try to get it connected with respect to voice. Voice is going to be reduced day by day, and the mobile data is going to be enhanced. You can see it in 2012 around, it is almost equal. Even it was the same scenario till 3G advance was enabled. Once it was there, when we will move away from the GPRS, or a Hutch communication network, and we come to this Vodafone and Airtel domain, then these things started, and now you can see there is no role of voice altogether with respect to the mobile tariff associated with the country. So what people are having the prediction, people are going to have prediction that what will be the total growth, associated growth with the billions of machine to machine or device to device connection is going to be in the term of 14 to 16 billion, where the key parameter will be the energy one, retail one, manufacturing and supply chain. Connected cars is going to be have highest CJCR, and this is taken from Cisco. So let's talk little more about IoT so that we could try to evolve what is MIMO and why it is required. Enabling various electronics devices to be connected to each other and the internet. It means if devices are connected to each other and they are not having net, it is not going to be Internet of Things, as it is clear from its name. And you have to give the control of those devices to a smartphone, which is easily accessible to each and every user. That is all belonging to the Internet of Things. So, and the data processing should not happen to the phone, as it is having the battery limitations. So it should happen in the cloud. If it is happening there, then you could say that it is Internet of Things, and you can do it with respect to all kind of consumers, smart infrastructure and security surveillances, healthcare, transportation, retail, industry, and others. So I hope you have studied these things in your lecture, where the people are teaching you from last 4 or 5 days. I am here to more discuss about the way standards behaves. So are we at the physical limit of, are we at the Shannon limit of the layer? तो उन्होंने कहा कि it is decided by K feature that the wireless industry is reached to its theoretical limit of how fast network can go. This is the starting point of MIMO. If we are at Shannon limit, we cannot access the systems associated with massive input, massive output. So there is another person who was the GSM Association Senior Director of Technical, D. Warren. उन्होंने कहा we are of the 99% of the way to the barrier known as Shannon limit. ये सारी बातें तब तक कही जा रही थी जब तक 802.11 नहीं आया हुआ था. I am talking about 2012. ये statements उससे पहले के हैं. These statements are before 2012. So in 2012, the statement is given that there is no theoretical maximum limit amount of the data that can be carried out on a radio channel. It is a technical term given by M. Goss, who is the definitive guide director for 802.11 wireless network, and this statement is given when 802.11 G and N is about to release, and from there effective unlimited capacity is possible via the personal cell or P cells. That statement is being made by the Parliament articles. So, are we on the Snell limit when we are talking about the 5G? That may be a possibility, but there is no limit as such. क्योंकि जब हम बात करते थे 2G के समय कि क्या कभी हम Mbps डाटा ट्रांसफर रेट अचीव कर पाएंगे, it seems that we are at Snell limit. When we talk about when we are in 3G, can we go up to 100 Mbps data transfer limit? People talk, no, it is the Snell limit. Then it comes 4G, where we are at the 100 Mbps data transfer rate. It was easily accessible to the people. Then people say it is the limit, we cannot go up to 5G. And then the 5G came, people achieve around 1 Gbps data transfer rate. And the research is going on. And as of now, people have claimed more than 100 Gbps data transfer rate. Even in my last talk to GL Bajaj, I have shown these people that how, with the help of electro-optical systems, lasers, and microwave combination, it means radio over fiber communication, people has achieved around 800 Gbps data transfer rate already in the system in the millimeter wave range. It means we are never going to reach on the Snell limits if we are considering the basic concepts. So what would Shannon say? We do not know the Shannon capacity of the why it is happening. मतलब हम बात कर रहे हैं एक limit की on the physical layer. So because we do not know the Shannon capacity of the most of the wireless channel, time varying channel with the interference or relay, cellular systems, ad hoc and sensor network, channel with delay, energy and money constraints, and Shannon theory provide design insight and system performance to the upper bound level. It means Shannon सामने सिर्फ एक consideration लिए हुए है, बाकी consideration नहीं लिए हुए. That's why he is on there. So let's come to the situation of the wireless systems, and then we will discuss the mind. So जो current situation है वो 4G आप use कर रहे हैं. इंडिया की मैं बात कर रहा हूँ. I'm talking about the India. I'm not talking about the abroad. There are few countries which they have enabled the 5G at their end. But India, we are at the 4G advance. And if 5G is about to come, it is not going to come in the millimeter wave. It will come in the 4.5G only in India, because operators are not in the condition to invest a huge amount at the millimeter wave, because the entire system has to be changed with respect to that. Similarly, 6G wireless LAN हम यूज कर रहे हैं 802.11 AX 5 GHz का बैंड इसको मिला हुआ है. कुछ जगहों पर हम इसका मिलीमीटर वेव बैंड भी यूज कर रहे हैं. We are using 5 GHz band, especially 5.8 GHz is the frequency which is being used in India, and some places it is 60 GHz for Wi-Fi, which is using the millimeter wave communication. Similarly, the millimeter wave massive MIMO system is already implemented in this 6G wireless LAN or Wi-Fi, where 802.11 AX is being talked. Satellite systems are there, Zigbee is there, Bluetooths are there, YGig is there. And what are emerging? The 5Gs are emerging. Now I should try to say that 6Gs are emerging. And in this, the 7G Wi-Fi system or the 8G Wi-Fi system, it is always 2 steps ahead. Wi-Fi networks are always 2 steps ahead with respect to the cellular network system. Why? Because their physical
Sorry for the interruption. Our speaker had some network issues. He will be joining shortly.
Okay. People should wait.
Yes, sir.
हेलो, क्या हुआ मैडम, कितना टाइम लग रहा है?
Sorry, sir. Actually, we are just reaching out and he's trying to join. So just please bear with us.
ओके ओके ओके, नो प्रॉब्लम.
Sorry everyone, I have some network issue here. It is very rare.
हाँ सर, मैं अभी तक फोन भी मैं कर रहा था सर, व्हाट्सएप सामने रखिएगा.
नहीं हाँ,
डन डन सर, नाउ यू आर विजिबल.
नहीं बंद कर दिया, बात हो गई. So I am here. आप मैं कहाँ से डिस्कनेक्ट हुआ था? Can you tell?
Yes,
सर,
sir,
this
yes,
is the
sir.
correct place.
So so these are the places where the researchers who are there in this domain, they should try to get work, and especially the energy harvesting and chemical and molecular system. Energy harvesting means you don't needed additional kind of energy in the point of charging. If you talk about the strong networks, then it means advanced home or smart home. Now no underground wiring is being taken place to give you supply to your instrument. It means once you enter in your home, without connecting anything, your all electronic devices are going to be get charged. Are you getting what I'm trying to say? मतलब आपके पास लैपटॉप है, मोबाइल फोन है, आपके पास आपकी एडवांस वॉच है, आपके पास और भी वाईफाई ब्लूटूथ स्पीकर्स हैं, आप घर में घुसे वो अपने आप चार्ज हो जाएंगे, आपको उनको चार्ज नहीं करना. These kind of systems are going to become with respect to this energy harvesting system, and then chemical and moleculars are associated with the body wearing devices, which is going to be the next one. So this is in principle version of the 5G, and where ultra dense network is required, where broadband networks are required to access, where we want to broadcast, we are in the mobility, we have the radio spectral efficiency, we have the visualization or virtual energy efficiency, we have the issue of automotive, e-health, IoT and public safety. All these are going to link with respect to the revenue. हर जगह पैसा ही इंपॉर्टेंट है. आज की डेट में हम और आप डिसाइड नहीं करते हैं कि हाउ द थिंग्स विल मूव. टुडे मार्केट डिसाइड हाउ द टेक्नोलॉजी विल मूव. That's why I told you that in India 5G will not come in the millimeter wave. It is decided by the cellular operator that they choose for a lower band. I will talk about that band also. तो सबसे पहला with respect to growth of time अगर आप देखेंगे तो वन चीज है टैरिफ बढ़ाया जा रहा है जिसपे बेस साइड लोकेशन पर आपको लेके जाएंगे and you have to increase there with respect to low data rates. It means when the Jio was not there, if people remember, they have to pay around 300 rupees for 100 Mbps data. Then Jio came and I'll make it free. You just have some recharge and then we give you all 1 Gbps data per day or 100 Mbps data per day. So if this is the situation, then you should have a uniform experience regardless of the locations. And in that case, your expense will reduce with respect to mobile data expenses and your revenue is going to be enhanced all the time. It means the only difference with respect to the enhancing traffic, that if your expenses are not reduced with respect to enhancing traffic, you are not going to earn from this particular business. If you are not going to earn, this is not going to be a profitable job. So let's come to the power consumption just to have an experience. अगर एक वाईफाई डाटा ऑफलोडिंग की बात करें और 4G LTE की बात करें तो उसके अंदर लगभग 8 लाख बेस स्टेशन होंगे. अगर 4G LTE की बात करें तो TD-LTE की बात करें तो इसको रन करने के लिए 60 गीगावाट आवर के हिसाब से पावर चाहिए. इवन 20 किलोवाट आवर पर BTX अगर आपने कंसीडर किया हुआ है बेस स्टेशंस के लिए पावर तो. लेकिन अगर वाईफाई डाटा अपलोडिंग चाहिए 4.2 मिलियन पॉइंट्स हैं यानी 42 लाख के करीब पॉइंट्स हो तो आपको ओनली 2 गीगावाट पावर कंजम्पशन चाहिए. सेम थिंग विद द 2G GSM फ्रीक्वेंसी की बात करेंगे. अगर आपके पास 8,30,000 है और आप 96 किलोवाट पर आवर BTS को पावर दे रहे हैं, उसमें आपको 80 गीगावाट पावर चाहिए. अगर आप यही सेम काम 3G में कर रहे थे जहां SCDMA टेक्निक आप यूज कर रहे थे इंस्टेड ऑफ GSM, तो आपके पास अगर टोटल बेस स्टेशन 3,50,000 थे, उस केस में आपका केवल 13 गीगावाट पावर जा रहा था. इसका मतलब क्या हुआ कि जो कंडीशंस हैं, इक्विपमेंट हैं, उसमें जो इलेक्ट्रिसिटी का शेयर है वो बहुत ही मेजर रोल प्ले करने जा रहा है. ठीक है. और इफ इट इज नॉट गोइंग टू बी रिड्यूस देन द रिसर्च इज नॉट गोइंग टू बी पे यू. सेम थिंग इफ यू गो फॉर द सेलुलर इंफ्रास्ट्रक्चर evolution with respect to 5G, BBU plus the radio head is going to be have some transitional base station and this is going to be used in the distributed base stations part. So if it is there, then in the traditional 1G and 2G, if you talk, either it is at 0.45 to 1.9 gigahertz, we have 8 dual polarized antennas and the peak transfer data rate which was achieved was 114 kbps. Here we use the distributed one. You can see in the picture that external, instead of external amplifier, we use the remote radio heads which are going to be located and which is going to be changed with respect to the array structures, and a fiber is being incorporated instead of the coaxial cable. It is very evident from the same structure. It is only 2.2 to 5 meter cable. Now we are using the 500 meter fiber. Instead of that, due to this fiber, the data transfer rate is enhanced to 150 Mbps when we are talking in the term of 0.7 gigahertz to 3.6 gigahertz. It will have minimum 8 plus dual polarized antenna. Let's talk about the 4.5G and 5G. Here you can use the fiber fourth haul or the cable which is connected with respect to the array of this structure or centralized base station up to 10 to 40 kilometers. At that time, the peak data rate will be around 10 Gbps and you will have minimum 128 to 512 active antennas associated by 3.4 to 6 or 20 to 60 gigahertz. Please note down these frequencies very carefully. I have told you people that in India we are not going to have 5G. We are going to have 4.5G in the first instance. That will work in the same domain where we are lying with respect to the 5G Wi-Fi. It will be the 4.5G. Once 5G will come, I will let you from a very recent literature published in the Oxford Journal, that I will show you there. Okay, what is the frequency which we are targeting now? So you can see with the just evolving some technology, you can enhance the data transfer rate from kbps to mbps and from mbps to the gbps, as well as you have a facility to keep your baseband processing unit away from the base station, where in one first case it is at the base station, in the second case it could be up to 5 to 100 meter, and in the third case it is up to 40 kilometer, because you will have the baseband processing unit in the virtual cloud mode. So these type of configurations are required if you are willing to have a energy efficient and network virtualization systems, where a resource pool that can support 10 to 100 cells with respect to collaborative radio, where the multi-cell joints scheduling processing, and a target platform for the IT, where you will have the lower power consumption, lower OPEX, and fast rollout. You just go by this system. This data is being published in 2013, and you can see the total energy condition in the general one is going to be reduced by 3.545 kilowatt to 0.86 kilowatt. That what is the demand of time. So what is the, now come to the topic. These are all the introductions, and I don't think it is only introductions. It is all about our understanding why these kind of systems required, or why we design a MIMO, or what challenges we should address when we are willing to design a MIMO antenna. That's why this presentation was in so much detail, and I'm talking in this much depth. Now I hope each and everyone has listened it carefully. If you have any kind of query associated this introduction part, please let me know, then we will go to the MIMO part. I am just asking you all.
Participants, if you have any query, feel free to unmute yourself and ask the question.
हेलो सर.
हाँ बोलिए, अजीत सिंह जी बोल रहे हैं.
यस सर, यस सर.
बोलिए.
Sir, in silent capacity formula, like C equal to B log 1 plus S by n to the base 2, why we consider base 2? Why not we consider sometime base 10 or any other base?
नहीं, how you read the mathematics, मैं भी आपको जब आगे बोलूंगा तो मैं बताऊंगा. देखिए ऐसा होता है ना कि अगर आप बाइनरी सिस्टम की बात करेंगे ना, वहां दो ही है बेस, 0 1, बाकी की कोई बात है नहीं. ठीक है.
Okay.
जैसे आप जब यूनिवर्स का एक्सप्लेनेशन देने जाएंगे ह्यूमैनिटी के टर्म में ना, इट विल स्टार्ट विथ मेल फीमेल. आप समझ गए बात?
यस सर, यस.
इसके अलावा कुछ है नहीं. आप कोई भी जेंडर ले लीजिए, कोई भी बात कर लीजिए. मैं कोई डिस्क्रिमिनेशन के पॉइंट ऑफ व्यू से नहीं कह रहा हूं, मैं जस्ट आपके अंडरस्टैंडिंग के पॉइंट ऑफ व्यू से कह रहा हूं. इट इज जस्ट ए सिंपल नेचुरल फिनोमेना. देयर विल बी ए चार्ज or a positive charge, there will be a negative charge, and they attract each other, or they will look. Is there a negative regular nature when we are going from 4G to 5G and 6G? एक क्वेश्चन है किसी का भाई. देखिए हाँ, ये
one question.
हाँ बोलिए जी.
Like as we see that antenna radiate electromagnetic like analog signal. So why we calculate like bit error rate in digital form?
नहीं, आप समझिए ना, हर चीज देखिए, हर काम आप. अच्छा एक छोटा सा सवाल पूछूंगा, प्लीज बुरा मत मानिए, पर्सनल सा भी हो सकता है थोड़ा सा. आपके घर में वेस्टर्न टॉयलेट है या इंडियन टॉयलेट है?
सर दोनों है सर.
दोनों है. आप कौन सा प्रेफर करते हैं?
मैं तो सर वेस्टर्न प्रेफर करता हूँ.
यस. क्यों करते हैं? क्योंकि वो कंफर्ट देता है.
यस सर.
एग्रीड और नॉट?
यस सर, यस.
हाँ, तो बट इट इज नॉट हेल्दी. आप उसका लिटरेचर पढ़िए, बताएंगे लोग इट इज नॉट एट ऑल हेल्दी. अब जो भी उसका बायो वाले वो, तो जो लीस्ट रेजिस्टेंस पाथ होता है, आदमी हमेशा वही पाथ फॉलो करता है. ठीक है. डिजिटल सिग्नल प्रोसेसिंग हमेशा डिजिटल में आसान है. आदमी क्या करता है, एनालॉग को डिजिटल में कन्वर्ट कर लेता है, फिर डिजिटल में सिग्नल प्रोसेसिंग करने लगता है. सिग्नल रिसीव करना एनालॉग में आसान है, आप एंटीना बहुत आसानी से बना सकते हैं, उसमें मॉड्यूलेशंस बहुत आसानी से कर सकते हैं। ये सारे सेकेंड वर्ल्ड वॉर के टाइम डेवलप टेक्नोलॉजीज हैं, तो उनको लेके आप वहां कंफर्टेबल हैं। और A to D कन्वर्टर्स की रिसर्च इतनी अच्छी है कि उनके कन्वर्जन में कोई इशू होता नहीं है। आप समझ गए?
यस सर, यस सर।
हाँ, अभी एक क्वेश्चन था, ये किसी ने पूछा था 5G 6G और ये वाला। आई वांट टू एक्सप्लेन दैट इफ यू आर गोइंग टू यूज एनीथिंग ना, if a man creates any system, it will always harm the nature.
सर मेरा एक बहुत बड़ा डाउट है।
सर एक मिनट, ये वाला क्वेश्चन का आंसर दे दूं, फिर आप पूछ लीजिए। जस्ट
जी सर,
2 मिनट, देन आई विल कम टू योर क्वेश्चन। सो मेरा जो कहना है वो यही है कि इफ यू गो बाय नेचर ना, ओनली द ह्यूमन बीइंग, आदमी, औरत, ट्रांसजेंडर की मैं बात कर रहा हूं, दे वियर क्लॉथ, इट इज अगेंस्ट द नेचर। बाकी कोई कपड़ा नहीं पहनता। आप बताइए अगर आपने देखा हो किसी जानवर को कपड़ा पहने हुए, बट हम पहन रहे हैं ना, क्योंकि हम थोड़े सिविलाइज्ड हुए। वो सेम थिंग विद द टेक्नोलॉजी, इफ इट इज विद इन द लिमिट, वी आर नोइंग दैट हाउ मच हार्म वी आर गोइंग टू क्रिएट ऑन नेचर एंड हाउ वी कैन कंपनसेट इट, इट इज ऑल ओवर। इफ वी आर नॉट नोइंग, देन इट इज प्रॉब्लमेटिक। Each and everything, the committees for which I am member, the Exposure Assessment Committee, I am member for International Electrotechnical Committee, TEC 106. I told you, just go on International Electrotechnical Committee. I am a member for the SAR evaluation system, for which I have developed an indigenous system here in NPL. I am member for that, and we used to discuss this part. There are two ways to do things. First one is the ride on time with technology. Second one is being lagged in the name of nature. Don't do that. There will be a mid path where you could be associated with the nature and also moving with respect to the minimum harm to the nature and moving with respect to the technology. Try to find out that. Suppose this data transmission rate and these technologies were not available, 5G, what will happen in pandemic? Each and everything will shut down for a year. So just being in critique to anything, just have an open mindset. It is also required. This technology is also required. You can access your each and every transaction. You can make payment without going to the bank. You can draw your payment without going to the bank. This is all happened because of this technology. So you have to give credit to this technology. But yes, when you are using a technology, it is having side effects. It is having impact on your life. And we have to be taken care in the term of standards which is talking. शर्मा जी, आप प्लीज अपना क्वेश्चन पूछिए।
सर मेरा एक डाउट बहुत दिन से है सर। आई आर ऑलवेज, ये केवल आपके सामने ही आई कैन प्रेजेंट बिकॉज दैट रिप्लाई ओनली यू कैन गिव। सर नॉर्मली रिसर्च आई हैव फाइंड आउट everybody is working in strip line, micro strip line for this frequency, wideband 30 gigahertz and all. But sir, when we go for base station, always you will find we are using conventional antenna.
Yes.
Parabolic reflector, drum or a dish antenna. So इसका रिसर्च तो कहीं होता नहीं। अब यूज हम उसको करते हैं।
बता देता हूँ।
So where this has gone?
मैं बता देता हूँ सर। एक्चुअली मैं थोड़ा सा ब्लंट हूँ, प्लीज मुझे थोड़ा बर्दाश्त करिएगा। People who are doing research in microstrip antenna, don't take it as a negative statement. I did my PhD in microstrip antenna for the loaded radiating structure in active and passive both.
Okay.
This is the first, मतलब मैं भी उसी फील्ड में हूँ जहाँ आप बात कर रहे हैं। ठीक है ना, मैंने भी PhD वहीं से पाई है। I did it from
ITVHU.
I did it from ITVHU, मेरी डिग्री यूनिवर्सिटी ऑफ इलाहाबाद की है, क्योंकि वहाँ काम नहीं था। तो जस्ट कम टू द पॉइंट। देखिए सर, ऐसा है ना कि ये एक तरीके का माया जाल है। जब आपको गेन अच्छा चाहिए, आपको हमेशा पैराबोलिक रिफ्लेक्टर ही यूज करना पड़ेगा। आपके पास ऑप्शन ही कोई नहीं है। एक छोटा सा, इतनी रिसर्च के बाद जो आप कह रहे हैं, मैं आपको अप्रूव करता हूं, वी कैन नॉट चेंज ए D2H एंटीना सर। उसका वो 50-70 रुपए का जो लोहे का टिन लगा के जाता है घर पे, हम आज तक वो नहीं बदल पाए। रीजन इज कि वो चल रहा है, वो छप जाता है, हमें भी थोड़ा सा नाम मिल जाता है, हमें भी अच्छा फील हो रहा होता है, हम कर रहे होते हैं। हम कभी भी ट्रू प्रॉब्लम्स की तरफ रिसर्च ही नहीं करते।
तो कैसे हम पहुंचेंगे सर आगे?
हाँ, उसका रीजन बता दे रहा हूं कि वो कैसे पहुंचेंगे। जब तक मैंने अभी आपको प्रॉब्लम्स दिखाई, उसमें मैंने आपको इशारा किया कि क्या क्या चीजों की जरूरत है। जैसे मैंने आपको बोला कि अगर आप ऐसा सिस्टम बना दें जिसको पावर ही आपसे ना चाहिए हो, जो वाईफाई नेटवर्क से चल जाए या इंटर नेटवर्क कनेक्टिविटी पे काम करे। हम सर क्या करते हैं, वी आर पिछलग्गू काइंड ऑफ गाइज हु आर रनिंग बिहाइंड वेस्ट। विद जस्ट किसी का एक पेपर छप गया, आप सब वेस्ट में जाइए, you will realize that because I have spent some time with my counterparts in Paris and East USA. There is a lab in Eleni, France. The name of lab is Eleni, France. It is competitor to us as far as national measurement is concerned. I have realized that they never do any research without industry funding. मतलब अगर उनको कोई काम करने को नहीं कहता है, वो नहीं करते हैं, वो अपना पढ़ते पढ़ाते रहेंगे. They never do research unless and until an industry person will come and ask them कि सर हमें ये requirement है, then they will do it. I will give an example of my student who just joined San Diego State University as a postdoctoral fellow. Okay? उनकी यूनिवर्सिटी में यूएस के लोग आए, उन्होंने कहा कि in spite of very well established water logging system, we have 20% of wastage of the drinking water. Why? Because when the rusting on the pipe occurs, we are not capable to identify. Can you make an antenna system? Can you make an antenna system where we can detect and imagine that this rusting is being started and this pipe needs to be replaced in next 6 months, 8 months, or 1 year or 2 years? If it is so, then we are capable to stop that leakage and we can save that water. आप इंडिया में जाइए, हर if you can find that there is a water tap being cracked out from the road and water is lying down on the. Nobody research on those problems, sir. This is the problem. Indian scientific community is serving to the West and optimizing their parameter on their software only. It is very shameful for us, I am telling, including me, that in spite of being IT super hub, we don't have any EM solver or software.
Sir, one छोटा doubt और sir, वो तो पता लग गया कि चलो गेन के लिए होता है, that is confident, sir. Why we cannot use optical fiber in transmission and we are using coaxial cable, rigid?
Yes. Sir, as the Ajit told, the answer lies in his answer. Your answer lies in his question.
Okay.
When you want to transmit an analog signal,
okay,
and you have a fixed kind of schemes associated with that one, the modulated scheme. Okay. At that time, you have to use coaxial. Otherwise, the modulation is going to be distorted. And this research is important, sir. अगर हम कोई रेडियो ओवर फाइबर ऐसा बना लें जो ईओ सिग्नल को वापस उसमें कन्वर्ट कर दे with the same modulation scheme which is required, then we can have that one. So I think there is no more question. I should move ahead with the presentation.
Please, sir. Please.
Sir, I have one question, sir.
Please.
Sir, can you tell me something about wireless power transfer for device driver? How the technique, I mean, the mechanism takes place over there?
देखिए, for wireless power transmission, two basic techniques are there. WIN-TRITY is the name. If you want, you can search it there. It is a MIT group. They have demonstrated magnetic resonance method. It means they try to transmit power with respect to 10 megahertz system in the lower frequency range domain. It means they have a source which is generating alternating current at 10 megahertz, and then they are capable to transmit power at a certain distance with respect to that one. So two things are important. First one, you should have a tank circuit concept associated with your driver, how much current and voltage requirement associated with your driver. If you are having the perfect knowledge for that, you can design any kind of magnetic resonance based system. If you don't want to do it, just do one thing: have a Wi-Fi router nearby it, have a Wi-Fi antenna nearby it. It will radiate around 1 watt per meter square. That what is the 1 watt is the feed power is allowed to that one, and it is having the gain of around 19 dBi. So if you are having a 19 dBi gain and if feeding is 1 watt, then you are easily going to get the power required to run your driver. That what is my expectation. I have not did it. But for the magnetic resonance method, I have seen people used to blow 60 watt bulb. My student just demonstrated 3 days back that we are capable to blow a 7 watt LED after removing all the circuit from the LED, which is at a distance of 1 meter. So you can try that part also.
Okay, sir. Thanks a lot, sir.
Thank you. So let me represent my case and then we will go where system. So is it is there?
Yes, sir. Yes, sir. Go ahead, sir.
So we have only two things to do. First one is to increase the transmission security without increasing the transmitting power. Second one is we have to increase the data transfer rate without any kind of extra spectrum or both combined. So let's come to the signal input, signal output mechanism where the time invariant channel was there and the maximum data transfer rate. This is the Shannon theorem, what he is used to talk. The C is equal to B log 2 1 plus S by N. And you can see that the bit error rate which is available here, it is going to be enhanced with respect to the signal to noise ratio. So channel capacity is enhanced if your signal to noise ratio improved. And with respect to modulation, it is having the different values. So signal to noise ratio, you are aware that कितना signal है कितना noise है, अगर उसका आप logarithmic scale ले लेंगे तो dB में होगा, otherwise वो non dB में होगा. So let's come to the MIMO system. So MIMO architecture is presented in 802.11n, that is the LTE, and just go and search in Google when it was invented. It was invented 20 years earlier. So the answer what Sarma sir is asking at that time lies here, that a technology which we are working today, it will be used in upcoming future when they will be capable to maintain the record of traceability, repeatability in their measurement, consistency in their measurement, compatible to complete the reliability of data as well as the coverage, then only they will use. इसका मतलब है कि जो माइक्रोस्ट्रिप एंटीना बना रहे हैं जिसकी बात सर कर रहे थे, वो आपके मोबाइल फोन में पहले लगता था. This is over. Now it is an array kind of antenna that I will show you later. And then the standards came. That's why institution like NPL have a bigger role when you are talking in the term of standards. It means when it is established in 2009, we should be capable to have the MIMO architecture measurement system with us so that we can perform. So सबसे पहले single user MIMO आया in 2009, फिर मल्टी यूजर माइमो आया. व्हाट इज द एंड फिर उसके बाद नेटवर्क माइमो आया जो इन फ्यूचर एक्सपेक्टेड है. इसका कुछ कुछ डाउट भी है जो हम डिस्कस करेंगे, बट ये तीन नेटवर्क जिसकी हम बात करते हैं. तो सिंगल यूजर में क्या है कि एक ही ट्रांसमीटर था, एक ही रिसीवर, हमें कुछ सोचना ही नहीं. फिर सिंगल यूजर से मल्टीपल यूजर ट्रांसमीटर, सिंगल एक ही ट्रांसमीटर जो है एक ही एंटीना में एरे लगा हुआ है रिसीवर पे, उनके दोनों को सिग्नल दे रहा है. फिर अगला टेक्नोलॉजी आया MISO, मल्टीपल यूजर्स ट्रांसमिट कर रहे थे आउटपुट को सिंगल यूजर को. और इसके बाद जो है ये सिंगल डाटा स्ट्रीम की बात थी. SIMO भी सिंगल डाटा स्ट्रीम की बात थी. और इसके बाद आया माइमो जिसमें मल्टीपल इनपुट भी था, मल्टीपल आउटपुट भी था. क्या फर्क पड़ता है इसका रियल लाइफ में अगर आप सुने तो जो सिंगल इनपुट सिंगल आउटपुट है, एक आदमी है उसके कान में गाना बज रहा है बट वो गाना उसको एक ही कान में सुनाई दे रहा है. देयर इज ए म्यूजिक विच इज एप्लीकेबल टू हिज ओनली वन ईयर. फिर अनदर पार्ट केम, देयर इज म्यूजिक विच इज अवेलेबल टू हिज बोथ द ईयर्स. नाउ बोथ द म्यूजिक सोर्स आर कनेक्टेड बट द ईयर इज ओनली वन. बोथ द सोर्स आर कनेक्टेड एंड इट इज अवेलेबल टू both the ears. It means both the ears are listening the same song with same phase.
सब नेटवर्क तो नहीं चला गया? पीपीटी होल्ड हो गया है सर.
Sir, screen is freezed. Okay, some network issues at the speaker's end.
Just we have to wait. Sir has lost connection.
Yes, and there is a short announcement that the paper submission in our international conference, that is MedCom 2021, has been extended to 25th of September. So you people all are invited that you can participate, and please register your papers in our conference. We will be happy to receive them.
This is Springer 1 and this is third series and Scopus.
Yes, sir.
ये आस्था मैम वाला वो शेयर कर दीजिए.
जी सर जी.
हाँ.
I will share, sir, the site as well, Abhi, because the speaker is not there, so we can have a detailed overview.
Yeah.
So this is our conference website. You can visit it at glbitm.org, Medcom 2021, and these you can go through. These are the call for papers, the important dates, paper submission guidelines. So here it's.
Asta ma'am, just hold.
Yes, sir.
Yes, hello. All attendees. Basically, this conferences cover all aspects of electronics. Whether it is a communication field, whether we have VLSI, whether we have signal processing. So in every domain, this conference will summarize all the things in every domain. Okay. So I am requested all the participants to just visit this site, and if you have any contribution in the terms of paper, then please submit it. The last date is extended up to 25th September. Okay, and it is gone in the Springer lecture notes in electrical engineering. That is the Scopus indexed. The previous conference which we have done is MedCom 2020, and the proceedings are online and also indexed in Scopus. So anybody who is interested in submit their paper, the date will extend up to 25th September. Okay. And the submission is all papers must be submitted via Easy Chair. Okay. And this is the ma'am link और उसके अंदर chat box में डाल दीजिएगा आस्था मैम.
जी sir जी.
Please share the link of the conference.
Yes sir. Already done sir in the chat box. Right now only I have done.
Okay.
Yes sir.
So all participants who are interested in submitting the paper in this conference, see the chat box. There is a link of the conference, and all the information will be there on that link. And if you have any queries, then contact us. We have my number, HOD sir number, and Dr. Kesh's number is there.
Yes, ma'am. Okay, we will be providing in the mail to all the participants regarding this conference. Right. Yes, and the conference date is in 29 to 31st October.
Asta ma'am, you have the mail IDs of all the participants?
Yes, sir. Yes, I have.
Okay.
And we will please, if anyone has joined today as the first day, so please do.
Okay, sir has joined.
Okay, sir. Please do attend the afternoon session. We will be providing attendance and feedback link. From there also we will get your contact details. So please do attend the afternoon session as well. So
हम engage कर रहे थे सर जब तक आपका network चला गया था.
नहीं, actually sir, they have keep our building in repair for today, for which I was not aware. Otherwise I will not present from here. It generally don't happen. We for entire building only one UPS and one network system is there. So we have to inform them in a earlier manner so that we could ask them to help us in that regard. Sorry for that.
कोई बात नहीं.
एक दो बार और होगा. So let's come to the problem which is there with single user MIMO benefits. First one is the diversity gain, and second one is the multiplexing gain. So receiver diversity and transmit diversity are the part of the diversity gain, and then the spatial multiplexing. If we are talking about the receiver diversity, it is going to be coherently complied multiple signals received by the multiple antenna. It means if single transmitter is going to send you signal, which two signals are being received by the transmitter, they have to be coherently complied. How? What is the meaning of coherently complied? The phase should be constant and the amplitude frequency should be constant. The amplitude should vary. It means suppose a signal is being routed through one obstacle, the other one is coming through a straight line or a free path loss domain. Then in both the cases, you are going to have the all kind of association in the way. Please fill it, Morgana. So what is the capacity gain? Capacity gain is nothing but CB log 1 plus SNR. When SNR is low, log SNR is 1 plus SNR is going to be the SNR only, and with respect to the data. Let's talk about the implementing receiver transmitter diversity. The transmitting is transmitting signal at various location, and it is receiving at the best antenna at various point. It is mentioned here from H1, H2, HNR, and you can see they are traveling a different distance with respect to that one. They can have obstacle in between. Suppose we are knowing what the signal is about to come, or which kind of signal is about to come, and we add a mixer at the receiver end with respect to a built signal, then we can have that Q1, Q2, Q3, QNR, and it can improve our signal to noise ratio, so that we could have a more better system. If we talk about the transmitter diversity, it means transmitter is sending signal to us. This is the situation was available in the maximum 3G. जब आपके एंटीना के अंदर एरेज नहीं होते थे, and then you are having only transmission from multiple sides, and when they are transmitting, and suppose there is a building in between the transmitter or the mobile tower between you, the one signal is directly sent to you, which is coming through the building. It may be dispersed, distorted, delayed, decayed, and not having correct information. The other one is routed to multiple reflection, and it reaches you by a different path, and both are going to be compiled. So then you have to check whether you are using the open loop transmission diversity or the closed loop. When open loop we are talking, it means we are sending the redundant version of signal over the multiple time slot through multiple antenna, and we will use a encode, the space-time block code, to ensure that multiple signals should reach at your end. This is the example. Here you can see in the first set, we are sending the signal S1 and S2 at a distance H1 and S2. So received signal will be H1 into S1, S2 into S2. In the second time slot, instead of S1 and S2, from the S1 we send a signal of S2 minus, and from this one we send the signal of S2 at H1 and S2, and receiver is going to receive this one also. So if you comply the diversity combination, if you apply here, it is going to square the H1 and H2. So it means the signal is going to be boosted from H1 square to H1 square plus H2 square. Suppose H1 is very low, then H2 will be do your job promptly. So in this open loop, we are not talking what signal is being sent from, can be calculated by the formula. ट्रांसमीटर डाइवर्सिटी, इसका मतलब क्या है कि यहाँ जो ट्रांसमीटर डाइवर्सिटी इनक्लोजर है वो क्या करता है, चैनल स्टेट इंफॉर्मेशन जो हमारा CSI है उसको एक बात बता देता है कि भाई मैं ऐसा कुछ भेजूंगा, उसको वो कह देता है कि भाई इस तरीके के वेटेज आपको दिए जाएंगे, these kind of weightage will be added to this one, and that is known to the receiver. So there is H1, H2, S3, H1 along with a feedback channel where all the data of these weightages is already provided to the receiver. In that case, suppose you send a signal, here you can see that transmitter send a signal at x is equal to e to the power j phi 2f into t, and RX may receive this or a pi phase difference between these two. मतलब ये signal इसके ठीक उल्टा पहुंच रहा है. It should be 180 degree turn around, but we are not knowing that. If we have a mechanism where this transmitter let us know that we have to reduce a pi from this signal, then we are going to get the same signal. That is called as closed loop transmit diversity. It means we are knowing which kind of weight is being going to be applied with respect to data, and that we applied when we are using the receiver so that we can get the same signal. That's why the CSI feedback is needed for pre-coding और लेटिंग अस नो कि जब इसको सिग्नल भेजा तो एक पाई डिग्री का पहले से ही घटा दिया जिससे कि हम उस पे पहुंच जाए. So this is all. They are having a equation. Suppose we have a two transmitting channel, and instead of x we receive x plus x 2x, then the received power becomes 4x square. So it is, you can see from this expression that 2x is going to be square, so the signal to noise ratio is going to be enhanced 4 times with respect to that limit, and the capacity gain can be defined by the same equation, whether the nomenclature is being changed, where W is the bandwidth, this is the signal to noise ratio that you have to check for the transmitter to receiver. Let's come to the spatial multiplexer. When we are talking about the spatial multiplexing, the form of independent links, यहाँ से यहाँ चला जाएगा, यहाँ से यहाँ चला जाएगा, ये वाला इधर भी, मतलब you can make any combination and send data in the parallel through of them. The problem with this system is there are going to be the crosstalk between the antennas, and the crosstalk must be removed by the digital signal processing algorithms. So let's consider one example. Here is a 2x2 MIMO. Here they are sending data in the term of H11, H22 to their nodes with respect to an X1, Y1 and X2, Y2. Now they are sending the cross signal H21 and H12 with respect to 2 to 1 and 1 to 2. So you are going to have the two expressions where Y1 can be expressed in the term of X1 and X2, and Y2 can be expressed in the term of X1 and H2 with respect to the two different combination of H. In case of Y1, H11 is there. In case of Y2, H22 is there. So, अब सबसे बड़ी problem क्या है कि we are having two unknowns and we are having only one equation. So, we are not going to solve this. We cannot solve the value of Y1 in this case. So, the problem with mathematics is it makes things complex just to get you solved. जैसे आपने पढ़ा होगा ना कि मतलब the Newton's version की जो God must be the perfect mathematician. Once he make this universe, he disappears. So same thing here. So the mathematics let us know that if it is true, then the minimum of NT and NR is going to be the asymptotic gain, and in the practice, the spatial multiplexing gain also depend upon the channel conditions. If we talk about the practical wireless device, multiple antennas are separated sufficiently far so that the channel is usually correlated. So multi-user MIMO comes into the picture. In the earlier cases, the Wi-Fi routers are having only one transmitter. That is called the single antenna network. If you want to connect them both with respect to this data, they may feel disconnected with respect to this Wi-Fi router, or they are having some crosstalk associated with this one. देखिए आप एक चीज समझ लीजिए, आप यहाँ जितना भी पढ़ रहे हैं, whatever you are reading here, it is related to your practical life. We all are advanced people. We just think that we are very modern, and this modernity comes into the picture when it is one-to-one connectivity. When it is one-to-many connectivity, this modernity disappear. I am talking you in terms of the normal situation. Suppose I am not older enough to say this example, but I am quoting it. Suppose a son who is adult enough, around 20-21 year old, doing BTech from your institution, come to a father and told, Papa, आज दोस्तों के साथ party है, मैं बाहर जाऊं. Should I go for party? Father will be very happy, and so is the Indian bent and modernity. I say, okay, please go. If the same thing happened to a girl, if she comes, then what will be the first opinion? The father will be, all the modernity will come to a shrink level. It means the crosstalk begin. Single antenna having two different desired data set will have the two different opinion. And why he is having fever? क्योंकि उसको पता है कि उसका बेटा ही बाहर गया हुआ. And the people like them are causing trouble to the girls. So this is also, if you needed two different data set, you needed two different antenna. That's why this multi-user MIMO comes, and that's why it is known as mu MIMO, which enables the data to be sent in different user parallel where no crosstalk interfere. आप ये काम टेक्नोलॉजी में कर सकते हैं, घर में नहीं कर सकते. It is not possible that you can do it in your home. So multi-user MIMO, how it works? It allow you, it says only one thing. जैसे आप घर में क्या सोल्यूशन निकालेंगे कि ठीक है बेटे को भी जाने दे रहे हैं, बेटी को भी जाने दे रहे हैं, लड़की पे एक रिस्ट्रिक्शंस ये लगा दिया है कि जब तू वहां पहुंच जाएगी तो वीडियो कॉल कर दे, जस्ट टू चेक. लड़के को ये कंडीशन लगा दी है, तू सड़क पे मत घूमियो, हम तेरा जीपीएस लोकेशन शेयर कर. So we are adding one weightage on them and allow them to do the crosstalk. So what they did, they just added a weightage signal W11 and W12 विथ रिस्पेक्ट टू x1 एंड x2। ऐसा आप इसलिए नहीं कर रहे हैं कि आप मॉडर्न नहीं है या मतलब आपको कोई दिक्कत है, आप बस सिक्योर होना चाहते हैं कि आपका बच्चा या बच्ची सेफ रहे। ऐसा जैसा सिनेरियो है, ऐसा नहीं कि कोई आप कंपल्सन लादना चाह रहे हैं, मैं आपकी मॉडर्निटी को कंटेस्ट नहीं कर रहा। आई एम जस्ट गिविंग दिस एग्जांपल बिकॉज इट इज यूज्ड हियर टू रिमूव द क्रॉस टॉक एंड इट कैन अप्लाइड देयर आल्सो। So W11 and W12 is added with respect to the weightage for the transmitter antenna, and second side के एंटीना के लिए हमने क्या किया, W21 and W22 यूज कर दिया। तो जो Y1 का एक्सप्रेशन था वो H11 की जगह वो जो X1 हम पहले लिख रहे थे वो इस वेटेज फंक्शन के हिसाब से आ गया, H21 के हिसाब से, ये फंक्शन के हिसाब से आ गया, और R1 only want XS1, so this equation reduced to this particular point. This is how this multi-user MIMO works. So अगर आपका जो ट्रांसमीटर है वो ऑब्टेन कर लेता है H11 H2X, इसका मतलब है कि आपको ये पता है कि W12 और W22 have to satisfy this equation which we have discussed here. This equation have to be satisfied by W11 and W22, and if this satisfy, if and only if the crosstalk interference from 2 to 1 is cancelled and we are in the zero forcing beam forming. This is called as zero forcing beam forming. मतलब हमने 1 to 2 के बीच के क्रॉस टॉक की सारी संभावना को खत्म कर दिया। मतलब जो अनाउंसमेंट हुआ, जो डाटा था, RX CSI जो मैंने आपको पीछे बताया हुआ था सिस्टम है हमारा कम्युनिकेशन का, उसने एक एक्नॉलेजमेंट जोड़ा हुआ है, एक एक्नॉलेजमेंट 1 जोड़ा हुआ है, एक एक्नॉलेजमेंट 2 जोड़ा हुआ है, एंड विथ रिस्पेक्ट टू टाइम दे ऑल आर अराइविंग एंड वी आर कैपेबल टू गेट द डेटा एसोसिएटेड विद द 2 ट्रांसमीटर। इट मींस in both the problem, whether it is girl or boy, you have to add some additional cautions due to the available environment situation. The same thing happening in the multi-MIMO, and from there you can use the number of transmitter as being enhanced. So instead of N, you are going to use NT. Similarly, NT users could be 0, but it should be a well-conditioned thing. Otherwise, you will find out some crosstalk or others. Similarly, can we do it on the large network? So that is a question where the research come into the picture. Only one transmitter at a time. The problem with the existing MIMO architecture is that you can use only one transmitter at a time. You can use the simultaneous transmission from the different transmitter, cause the collision kind of situation. Collision means we are not capable to acknowledge what acknowledgement is being associated and how we can differentiate them. If it is so, then how it is going to be measured? And a gained MIMO is being considered, where the wire in hall is being connected between all the Wi-Fi routers, so that you are knowing the mutual interference value can be cancelled out, and you are having a synchronized and shared data. मैंने आपको बोला था ना, पीछे आपको दिखाया था कि ट्रांसमीटर ही बता दे रिसीवर को कि हम तुम्हें कौन सा वेटेज भेजने वाले हैं, which kind of weightage W11, W12, W21 and W22 is going to be used. That should be informed already by this transmitter to all these receivers, and they should be synchronized ones so that it could happen in a normal way. But it can happen only in a linear way. In a network MIMO, this is a complex question. It is not yet possible. I am writing it infeasible, but it is not the situation. Because we need to require full kind of synchronization, carrier, phase, frequency, sample clock, data transmission rate, latency, and full data sharing along with the CSI exchange. How this is going to be possible for a non-linear system, that is a matter of challenge, and it is have to be realized, and this is going to be the basis of upcoming 6G network. उन्होंने सोल्यूशन क्या दिया है इसका? उन्होंने कहा कि हम ऐसा करेंगे नहीं, हम क्या करेंगे कि हम इनके फेम्टो सेल्स बना देंगे, नैनो सेल्स बना देंगे, फेम्टो सेल्स बना देंगे, और डाटा ट्रांसमिशन को इस वे पे ले जाएंगे कि आइदर दे आर कनेक्टेड थ्रू फाइबर, और दे आर कनेक्टेड थ्रू मिलीमीटर वेव, और दे आर कनेक्टेड टू 2G और 3G स्पेक्ट्रम. And on the basis of those differentiation, we will apply the CSI exchange, and from there it will be happen. So जब आप 6G देखेंगे तो ये नेटवर्क MIMO एक यूजेबल थिंग होगा, और इसको जो है आप यूज कर पाएंगे मल्टीपल सिस्टम्स के साथ, मल्टीपल डाटा के साथ, और इसको जो है धीरे धीरे आप बढ़ा पाएंगे. सो लेट्स कम टू द पेपर विच इज पब्लिश्ड जस्ट 28 जुलाई 21. ये आपको सब बैंड्स की बात कर रहा है, डिफरेंट डिफरेंट फ्रिक्वेंसी के. सो आप ये ध्यान रखिए जो मैंने आपको पीछे बोला था कि आपकी फ्रीक्वेंसी ये होने वाली है 5G की इंडिया में। LTU का जो यूनिवर्सल बैंड होने जा रहा है 5.15 टू 5.925 के आसपास कहीं होने जा रहा है। बाकी डिफरेंट डिफरेंट चैनल्स उनके नंबर्स हैं डाटा ट्रांसफर के हिसाब से। इधर भी कहीं हो सकता है 3.3 टू 4 के बीच में भी, क्योंकि ये बैंड भी अभी खाली है। इंपॉर्टेंट बात यह है कि अगर आपको जीबीपीएस डाटा ट्रांसफर रेट चाहिए तो आपको मिलीमीटर वेव में जाना पड़ेगा, और उसके लिए जो बैंड एलोकेशन किया गया है वो 24.25 से 39.5 गीगाहर्ट्ज का किया गया है, या 37 से 43.5 का किया गया। ये बैंड आज की डेट में एप्लीकेबल है दुनिया के लगभग हर उस देश में जहां पर ये कनेक्टिविटी है और वो कनेक्ट कर रहे हैं अपने आप को 5G के साथ। So this band is applicable throughout the world, for which they are using the systems, and these are the antennas. The question which was asked, just look at the antennas type which is used in the MIMO: monopole, dipole, miniature dipole, fractal antenna, IFA, PIFA, AVA, and slotted loop antennas. They are having some advantages and disadvantages. All these are cited from this paper. This is how they are going to use. A simple example is being considered here. जो हम जरा बात करते हैं मेजरमेंट के टर्म में, कि आपने एक सिमुलेशन एंटीना डिजाइन कर लिया जिसके 6 एरे फैक्टर हैं। तो सबसे पहला आपका काम क्या है कि इंडिविजुअल माइमो का क्या मतलब है कि हर एंटीना के लिए एक फीड दिया गया है। देयर विल बी फीड फॉर ईच एंड एवरी एंटीना। तो पहला आपका काम यही है कि अगर आपने एक एंटीना एक पर्टिकुलर बैंड के लिए डिजाइन किया है तो उसके सारी रेजोनेंट फ्रीक्वेंसी जो एंटीना का रेजोनेंस बिहेवियर बताती है या जो उसका इंपेडेंस कैरेक्टरिस्टिक शो करती है वो S11 से लेकर के S66 तक जो है वो शो करे सेम फ्रीक्वेंसी पॉइंट्स पर। इसके अलावा इनका एक दूसरे पे क्या इफेक्ट है, व्हाट इज द म्यूचुअल कपलिंग बिटवीन देम। इट मींस यू हैव टू स्टडी द ट्रांसमिशन बिटवीन S21, एक पोर्ट यहां लगाया एक पोर्ट यहां लगाया, देन यू आर गोइंग टू मेजर द S21 S, if this is the first antenna, then this is the S31, this is the S41, this is the S51, this is the S61, and this is the S21. आप ठीक ठीक समझ लीजिए कि एक पोर्ट को कांस्टेंट रखते हुए बाकी सारे पोर्ट मेजर करते चले जाएंगे। उस वन के रिस्पेक्ट में इसका जो भी नंबर होगा उसको पहले लिखेंगे और दूसरे नंबर को बाद में लिखेंगे। इट मींस सपोज यू आर मेजरिंग बिटवीन दीज टू पोर्ट्स, द नंबर विल बी S21, which is going to give you the loss, and from there you are going to know the mutual coupling, and it should be given driven by a certain lower value, and from there you can evaluate the SAR of the system. So mutual coupling, antenna characteristic, that you have to measure. And if you go by the parameter like antenna efficiency, these are the parameters which are required if you are designing MIMO in the 5G. This reference is also taken from the same paper. That paper is free. You can download it from the net and read it. So either your efficiency is compromised or your isolation is compromised or your ECC is being compromised. Whatever it is there, isolation's key parameter are the gain, antenna efficiency, which includes the gain and the isolation. आप दो पैरामीटर को देख के चलिए. These are the antenna type. So these will be the future antennas if you are using them either in terms of monopole or anything else. And this is how the single user MIMO and multi-user MIMO complexity of the transmitter and receiver is being settled with respect to the base antennas. And this is the hardware. Just come to have a few beam forming lessons associated with the data. That is the MIMO array antenna. Here multiple transmissions is being taken place to the single one, and it is being beam formed with respect to a single data stream. So you can see instead of 16 antenna beam forming with the 62 cross that MIMO, you are going to use the 32 antenna with respect to the 8 cross 2 MIMO. Why it is possible? Because you are using phase as a cancellation unit. This is the most complex structure associated with MIMO structures, where you can see that the digital IQ data is being processed. The key association with the DSP or digital signal processing is that you are capable to analyze the phase part, which is the requirement in the 5G, and then you use them with respect to your requirement, so that you use a dual pole or antenna. And this is a normal MIMO sub 6 gigahertz standard, where frequency is considered at 2.5 to 3.4 gigahertz, and if RS DSP is being considered to analyze the signals. And this is the typical massive MIMO beam forming structure is there. Here you can see that this is the MF antenna, where the measurement probe is connected with respect to a measurement equipment, and this is the transmitter. These are the, and this is the RF receiver chain which is connected with respect to this one, so that you could have both the combinations. And it is have, earlier it was analog beamforming in 3G, digital beamforming, and now we are trying for the hybrid beamforming. And the challenges are the bottleneck associated with the MIMO, where the people should work in their research. That is the first, it's connectivity with respect to the cloud, which will enhance the cost. Second is the calibration. Third one is the mutual coupling. Fourth one is the irregular arrays, and fifth one is the complexity. Let's talk one by one. Limitations on the digital IQ are the on the fiber. जो डिजिटल IQ है उसके साथ प्रॉब्लम क्या है कि एक बार सिग्नल जा करके राउंड ट्रिप टाइम जो लेता है वो अराउंड 1 मिलीसेकंड की हम लेटेंसी की बात करते हैं 5G में। अब जो सब फ्रेम प्रोसेसिंग है वो 400 से 800 माइक्रोसेकंड के टर्म में है। जो फाइबर ऑप्टिक्स का राउंड ट्रिप टाइम है वो इट इज अराउंड 200 to 400 माइक्रोसेकंड। सो व्हाट विल बी द मैक्सिमम रेडियस? इट विल बी अराउंड 20 to 40 किलोमीटर। If you want to reduce these latency from 1 millisecond to say 110 microsecond or something else, this will further reduce this radius. And similarly, if you talk about the CPRI data bottleneck, CPRI means common public radio interface. So here the bandwidth is given in the term of sectors, overheads, line coding, and the bits per sample. Here you can see, if you have 32 antennas, then you can have the 10 Gbps data transfer rate. But if you go by, this is the IP data transfer rate which is happening with respect to the systems which is available, and this is the common public radio interface. It should happen with respect to a speed of 786. So another problem is the active array antenna problem. If you zoom this problem, then you will realize. Just see, अगर आपने कोई एम्पलीफायर स्ट्रक्चर्स यूज कर रखे हैं तो जो आउटपुट पावर होगी वो 25 डिग्री सेंटीग्रेड पर अगर वो प्लस 46 dBm यानी अराउंड 40 से 50 वाट पावर दे रहा है तो सीधा घट के 44 dBm पे आ जाएगा. इट मींस इट इज नॉट ए स्टेबल काइंड ऑफ जॉब, इट इज वेरिंग विद रिस्पेक्ट टू टेम्परेचर एंड इट इज नॉट एट ऑल यूनिफॉर्म. यू हैव टू मेजर देम ऑन ए रियल टाइम सिनेरियो. Same thing with the respect to phase tolerance. If you compare the output signal with respect to power in dB, then you are going to have a loss, a variation of 20 dB output signal power with respect to phase angle at a particular 90 degree angle, where we are very much interested in. So this should be a case of calibration where the multiple MIMO should be calibrated. This is the another problem, that is the mutual coupling. You can see that these coupling structures is being generated and they are not in the perfect conditions, and this RNS, ZNB and these structures are being used just to know the mutual coupling. These structures, these systems are also made by Keysight as well as the NSU. It is up to you which you want to procure. I am not advertising them. This PPT is available on RNS website, so I have taken it from there. So it is just for their acknowledgement. Third and last parameter is the active return loss measurement. You can see the passive return loss is represented in red line, but when these cells are active, they have shown a different return loss characteristic. How you are going to compensate them? So these type of structures make irregular array. Here is the absorbed into the environment structure. Here you can see these are the arrays which is made on the buildings, which is in the form of their logo, and these are having the different kind of side lobes and low mutual coupling associated with them. So we have to go by these kind of structure, and then we have to perform the measurement. So just come to the measurement part, which is last in my presentation. I will try to complete it next 10-15 minutes so that we could go. So अगर आप एंटीना का रेडिएशन पैटर्न समझते होंगे तो उसके 3 जोन है. एक नियर फील्ड का जोन है, एक फार फील्ड का जोन है. नियर फील्ड में 2 जोन है. देयर आर 2 जोन. फर्स्ट वन इज द नॉन रेडिएटिव जोन, अदर इज द रेडिएटिव जोन. The more complex measurement lies in the reactive zone, that is the non-radiative one, and from there you are going to use this one. So अगर आपका एंटीना अंडर टेस्ट, AUT means एंटीना अंडर टेस्ट का साइज 0.5 मीटर है और आपकी फ्रीक्वेंसी जो है 6 गीगाहर्ट्ज है, तो आपका चैम्बर साइज कितना होना चाहिए? इट इज अराउंड 10 मीटर। अगर यही सेम काम आपको 30 गीगाहर्ट्ज के लिए करना है तो आपका चैम्बर साइज होना चाहिए 50 मीटर। अगर यही सेम काम आपको 1 मीटर पे करना है, अगर 1 मीटर एंटीना साइज के लिए करना है तो आप, और फ्रीक्वेंसी आपकी 6 गीगाहर्ट्ज है, तो आपका चैम्बर साइज होना चाहिए 40 गीगाहर्ट्ज। चैम्बर साइज कहने का मतलब है कि एक एनाकोइक एनवायरनमेंट जिसमें बाहर से कोई भी एक्सपोजर आ करके आपको डिस्टर्ब ना करे। 2d स्क्वायर बाई लैम्डा एक जनरल टर्म है जो फार फील्ड के लिए यूज किया जाता है। जो नियर फील्ड डोमेन है उसमें लगभग डी और लैम्डा बराबर होते हैं। जो रिएक्टिव वाला जोन है उसमें ये फॉर्मूला नहीं लगता है, इट विल बी 0.62 अंडर रूट डी क्यूब बाई लैम्डा का लगेगा। और एक नॉर्मल जोन के लिए जहां पे 2.69 गीगाहर्ट्ज हमने बेस स्टेशन ले रखा है विद 8 एलिमेंट एरे, जो रिएक्टिव फील्ड जोन है वो 0.6 मीटर का है। ठीक है, तो अब नापे जाने का क्या तरीका है इसको, क्योंकि इतने बड़े चैम्बर्स आप बनाएंगे कैसे, बनाएंगे तो उनको मेंटेन कैसे करेंगे, और मेंटेन कर भी लेंगे तो करेंगे क्या उसका उतने बड़े सिस्टम का। तो कुछ स्कीम्स प्रोड्यूस की गई। एक ये सिस्टम प्रोड्यूस किया गया ईरान के एक साइंटिस्ट के द्वारा, जो इस समय हु इज वर्किंग इन यूएसए, एंड व्हाट हिज कंसेप्ट वाज कि इफ यू नो द सर्कुलर वेव फ्रंट एंड इफ यू नो द पॉइंट सोर्स एंड इफ यू नो हाउ इट इज वेरिंग from the circular to planar, you can move, you can characterize these phi into the planar wavefront. This is how the wave is being framed, which is I have shown you earlier. From here you can see earlier they are spherical in nature, and when they move higher side they are become straight lines. That's what is happening here. Here they are more spherical and here they become more and more straighter. This is so one solution they have given कि we apply a dielectric lens here which can convert these spherical wave fronts into the planar one that can be used. So this is their planar wave converter where you can see that this structure is being used against this antenna, and what is the role of this structure? This is the dielectric lens which is converting all the spherical wave front into the planar one. So हम कर क्या सकते हैं, हमको free space path loss measurement करना है। तो what we did at NPL, we took 2 antennas which are in the near field domain, and in near field domain we apply antenna under test at this circular table and the probe at the other table, and we consider 2 angle of rotation. One is the azimuthal one and other one is the elevation one, and from there we move this antenna for greater than phi or the less than phi, and for this particular phi we are moving it from 0 degree to 180 degree. It means we are rotating the lower antenna, and each antenna when it rotates to 1 degree centigrade, for the phi consideration the theta is being varied from the minus theta to plus theta. This is how it is going to be scanned, and it is scanning at various distance so that we are capable to convert spherical front to the polar one, and from there we are going to calculate the near field scanning, and from the near field to far field transmission we are going to get the radiation pattern associated with this one. So let's come to the example part where the simulation is being carried out. This I have get on academia in 2009, where they have tried to explain you the diversity from the simulation of CST, and it is available for preprints, and no copyright issues there, so we are using this one. So just see this MIMO antenna diversity. Here is the signal strength. You can see there are dip at various strength with respect to the time, and this is happening because of the signal overlay resulting in that dimension. It means your antenna ki positions hai, either they are making some problem and we have to overcome by this problem. How we can overcome by this problem? Firstly, we have to try to understand that the diversity gain is the relation between these two parameters, and we have to consider the role of scattering parameter associated with those elements as well as the interchange between those elements, and from there we could have a broadband correlation result, and that can give you a diversity phi gain. So from there we can have a correlation in a free space, and we are now getting a good agreement value that is nearer to the 0.01 or 0.016. That's what we have get, and from there we can analyze that what will happen when it is correlation with a scattering object. It means suppose you are using a human being behind this antenna or behind this structure, then how much enhancement is going to see in this correlation value that is well within the far field range, and we have decided the range is 0.0239 by the far free space law formula, and we are getting the correlation of 0.02. So we are in a disagreement mode. So what we have to do, we have to correlate over the distance. So what we will do, firstly we will measure the antenna in the free space, and we will plot the far field as well as the scattering parameter with respect to both. We evaluate the correlation in the 1D result. Again we will use the phantom which is placed inside behind this antenna, and we will calculate the scattering parameter. After calculating these two, we are going to get the gain and a correlation value associated with this one, so that we could have a correlation and a diversity gain with respect to the antenna. Similarly, the pattern diversity, where you have to reduce the mutual coupling, correlation, capacity, diversity gain, total active reflection coefficient. For that, firstly we will design the single antenna, and we will get a radiation pattern characteristic antenna, and then when we will have that kind of structure, we will go and do the adaptive mesh refinement with respect to that one, and we will try to get a more better result with respect to the mesh refinement. Now let's come to the investigation part. Now from this PPT, it is clear that we have get the best result in the term of pink one and the blue one. Whichever you want to choose for the energy based system. Now we have to make an identical antenna of that particular line width, and for that, where we should keep that antenna, we perform a study. Here you can see that 3 orientation is being considered. In the first, both are looking at each other, or both the slots are in the same direction. In the second, both the slots are in different direction. In the third one, we have considered them at a different corner of the patch slot. So if you check the mutual coupling, just go by the name. 2.1, 2.2 and 2.3 is the name. In case of 2.1, we are getting the S11 at 2.6 around, which is the design frequency, and mutual coupling is at a lower value, which is not the lowest, but it is not below 2020. Similarly, 2.1, we can see the results. It is for the 2.2. Now you can see the results. Similarly, it is for the 2.3. You can see the results. It is now we are coming closer to that one. So best arrangement will be this particular structure, where the coupling loss is mutual coupling loss is minimum as compared to these two structures. Similarly, now we will go for the correlation coefficient, which is given by this formula. You can apply these correlation coefficient and diversity gain from here, and then you are using this. Then you could find out a more better situation with respect to the 2.1, 2.2 and 2.3, and then there you can choose the value which is coming nearer to the 2.6, and from there you can go and design a phase shifter, which will give you a more better result with respect to the phase variation. And this is how you could design your MIMO structures. So this is all from my side in the presentation, and I hope you people have enjoyed. If you have any question in the MIMO, please ask.
Sir, thank you, sir. Thank you very much for such a informative lecture, sir. मैं सर एक मेजरमेंट से रिलेटेड क्वेश्चन पूछना चाहता हूँ.
बोलिए जी, बोलिए.
सर, एंटीना है जिसमें 8 हॉरिजॉन्टल बीम है और 8 वर्टिकल बीम है.
जी, ठीक है.
तो मेजरमेंट किस तरह से हो सकता है, या मेजरमेंट फैसिलिटी यहाँ कहीं मिल सकती है?
नहीं, आप पोलराइजेशन मेजर करना चाहते हैं, जितना मैं समझ पा रहा हूँ.
नहीं, एंटीना एक्चुअली उसमें 16 चैनल्स हैं, 8 हॉरिजॉन्टल और 8 वर्टिकल.
तो
क्या कह सकते हैं? हाँ, 16 पोर्ट हैं.
हाँ, ठीक है,
पोर्ट हैं. तो उसका मेजरमेंट कैसे पॉसिबल है? यहाँ पॉसिबल कहीं हो सकता है इंडिया में?
नहीं सर, उसमें पॉसिबिलिटी आप क्यों खोज रहे हैं? मैं आपको सोल्यूशन बता रहा हूँ. आप 8 चैनल को फीडिंग कैसे देने वाले हैं, पहले आप उसके बारे में सोचें. आपको 1:8 के 2 पावर स्प्लिटर लेने पड़ेंगे. ठीक है, हेलो, आप मेरे को सुन रहे हैं कि नहीं? आप अपना माइक बंद कर लीजिए, मैं बोल रहा हूँ. आप निश्चित. हाँ, आप जो है 1:8 के 2 पावर स्प्लिटर ले लीजिए. ये मिनी सर्किट्स पे आते हैं, महंगे होते हैं, रेंटेड मिलते हैं, आप ले सकते हैं, कोई ऐसी दिक्कत नहीं है. आपको एक वेक्टर सिग्नल जनरेटर की जरूरत होगी. अगर आपके पास नहीं होगा तो आप हमसे कांटेक्ट कर सकते हैं, हमारे पास है. उस वेक्टर सिग्नल जनरेटर से हम 2 आउटपुट लेंगे, एक आउटपुट को हम जो है एक पर्टिकुलर डायरेक्शन के लिए मोटिवेट कर देंगे, मतलब एक सर्टेन एंगल उसमें ऐड कर देंगे और दूसरे को नॉर्मल रखेंगे और दोनों के केस में देख लेंगे। इसमें कोई ऐसी बहुत बड़ी चीज नहीं है।
Sir, we have some questions in chat.
अरे मेरा पहले फर्स्ट मेरा
अच्छा
नंबर है
सर, HOD sir, yes sir, special expert question.
धीरज जी थोड़ा माइक बंद कर लीजिए।
Yes sir.
धीरज सर का डिस्टर्बेंस थोड़ा सा आ रहा है। ओके सर, एक्चुअली मेरा क्वेश्चन एक टोटल प्रैक्टिकल है। सपोज वी हैव सम 8 एंटीना सिस्टम जो है, ट्रांसमिशन एंड रिसेप्शन सेम 8x8 प्रॉब्लम। सपोज डेंसिटी अनुसार, आई एम आस्किंग अकॉर्डिंग टू डेंसिटी, सपोज दिस एरिया मैक्सिमम यूजर्स आर अवेलेबल, can we divide our power in transmission in particular sector maximum, and where the less users is available that side power should go minimum?
बिल्कुल कर सकते हैं सर। इसके लिए बीम फार्मिंग का कंसेप्ट होता है, और बीम फार्मिंग के कंसेप्ट में हम क्या करते हैं कि अगर हमें ये पता चल जाए कि ये पर्टिकुलर एरिया से जो टेली डेंसिटी है या जो टेलीफोन की लेटेंसी है वो मैक्सिमम की जा रही है, तो आप उस पर्टिकुलर एरिया को लिंक कर सकते हैं कि हमारी जो स्कैनिंग होगी, इंस्टीड ऑफ अभी आज की डेट में क्या सिचुएशन है कि आप ज्यादातर लोग, हम लोग जो हैं वो अपना जीपीएस डाटा ऑन रखते हैं, तो जो बीटीएस है वो क्या करता है, वो एमटीएस को बताता रहता है कि ऐसे ऐसे बीम चलाते रहो, ठीक। जैसे तो अभी अगर आपको अगर ये इतना क्लियर है कि भाई ये पॉपुलेशन, जैसे लेट्स से आप नोएडा की बात करते हैं कि एक पर्टिकुलर टावर में मल्टीपल पॉपुलेशन रह रही है, दूसरे टावर्स खाली हैं, तो हम उसको फ्रेम कर सकते हैं कि उसकी स्कैनिंग सर्टेन उसी पर्टिकुलर डायरेक्शन में हो, बाकी जगह पे ना हो।
हाँ ऐसा। अच्छा, दैट पावर डिवाइडर सर्किट इज देयर, इट मींस।
हाँ यस इट इज देयर।
ओह थैंक यू सर, थैंक यू।
उसके बगैर नहीं होगा। हाँ
ओके सर, थैंक यू।
हाँ, ये और किसी का क्वेश्चन था, कोई और भी कुछ कह रहा था कुछ?
ये मिस्टर गंगा सागर वर्मा ने डाला है, इज इट पॉसिबल टू डिजाइन एंटीना टेम्परेचर सेंसर फॉर माइमो? If yes, then which software we use for design antenna temperature sensor?
मैडम देखिए, 2-3 चीजें हैं। आप लोग मतलब कोई भी चीज इम्पॉसिबल तो है ही नहीं, ठीक है। और सब का सब जो है ना, जो वीन्स डिस्प्लेसमेंट लॉ जिन्होंने फिजिक्स में पढ़ी है ना, कि जो डिस्प्लेसमेंट होता है एटॉमिक स्ट्रक्चर का, वो टेम्परेचर का ग्रेडियंट होता है। इसका मतलब है कि वेवलेंथ हमेशा टेम्परेचर से रिलेट करती है। वेवलेंथ, अगर कोई भी वेवलेंथ हुई, माइक्रोवेव हुई या लोअर फ्रीक्वेंसी हुई, वो हमेशा टेम्परेचर से रिलेट करेगी। बात ये है कि इज इट इजी टू मेक ए सेंसर बाय यूजिंग माइक्रोवेव और नॉट? सो माय जेन्युइन सजेशन टू दैट गाय इज यू शुड ट्राई आईआर फर्स्ट, बिकॉज आप सेंस किसको करना चाहते हैं। इफ यू वांट टू मेजर द इंटरस्टेलर टेम्परेचर ऑफ ए सन और ए मून और ए स्टार, देन माइक्रोवेव इज वेरी गुड. If you want to measure temperature from body, why you needed a microwave unnecessary to be exposed on a human being? Should be done by IR. So depending upon your application, you can use it by the Wien's displacement formula. It is very much possible. You have to just know the Boltzmann constant and Maxwellian Boltzmann distribution velocity, so that you could have a interconnectivity with respect to the data. That's it. And the software part she has asked, it is based, आज की डेट में FPGA सर्किट्स अवेलेबल हैं, एड्रीनो बेस्ड सिस्टम अवेलेबल है, रास्पबेरी पाई अवेलेबल है, जिनके अंदर आपके कॉलेज के बच्चों ने बीटेक के प्रोजेक्ट बनाए हुए थे कि आग लगेगी तो पानी चल जाए, तो उसमें क्या कर रहे थे वो? दे आर हैविंग IR सेंसर्स, व्हेन द टेम्परेचर राइजेस दे मेजर द टेम्परेचर, एंड देन ए रास्पबेरी पाई इज देयर कि देयर इज ए ड्रिफ्ट इन वोल्टेज विद रिस्पेक्ट टू दैट टेम्परेचर, then they will give a command to the water supply, just switch on the power, बात खत्म, और उनका मोटर ऑन हो जाता था, पानी चलने लगता था. So it can be done on various platforms depending upon your capability. If you are comfortable in Python programming, Raspberry Pi and Arduino is very good platform to make this kind of tiny sensor, even this kind of, and it will have a very good accuracy.
Yes, sir. Thank you, sir, for such an extensive explanation to the question. Next question is, how and why microwave component is different from light wave component?
That is a very nice question. I am willing to answer it in more common way rather than more technical. देखिए, ऐसा है कि सारा मामला ये है कि वेवलेंथ है. वेवलेंथ का मतलब आपको पता है c by lambda का मामला है. F is equal to c by lambda. C फिक्स है, तो जब C फिक्स है तो जैसे ही मतलब क्या सेंस हुआ कि एक पाइप है, उसका डाया फिक्स है, तो अब या तो पानी आपको सोर्स से तेज भेजना पड़ेगा या आपको मुंह पे दबाना पड़ेगा, तभी आगे होता है ना. आप घर में पौधे को पानी देते हैं तो क्या करते हैं? हाउ यू डू इट? जो या तो आप अपना टैप फास्ट कर लीजिए जिससे इंसिडेंट वाटर का फ्लो तेज हो जाए, या आप उसको टैप को बीच से प्रेस कर दीजिए, जो 2 हिस्से में बढ़ जाए, पानी तेज जाने लगे। दिस इज ऑल यू हैव टू डू। तो व्हेन योर वेवलेंथ बिकम स्मॉलर, say in nanometer order, your component become very tiny and they will react with respect to their EM wave propagation phenomena, nothing else. When they are in centimeter or millimeter order of the wavelength, which is microwave, which you are willing to talk, it will having a different dimension where optical cannot propagate. So you needed that kind of devices. So splitter, chopper, function generator, all are there in optics also, and they are also available in the microwave, but they are working in the different frequency domain, so their dimensions are different. And ये वैसे ही है जैसे आपका ससुराल मायका है ना, जो एज ए सन मैं अपने घर में मेरी जो स्थिति होती है उससे बहुत ही अलग स्थिति मेरी ससुराल में होती है। लोग पता नहीं किस बात की इज्जत कर रहे होते हैं, बट कर रहे होते हैं, मतलब आपको बहुत ही। तो ये वही मामला है कि आप घर में कुछ होंगे, ससुराल में कुछ और होंगे। तो वेवलेंथ बदल गई है, वहां आप जमाई हैं, यहाँ आप घर की मुर्गी छाक बराबर है, बाहर निकलो करके दो ये काम। सो इट इज द सेम सिचुएशन। इसको इसके बियॉन्ड मत सोचिए, ठीक है ना। आप वेवलेंथ बदल जाएगी, काम बदल जाएगा, आपको वही सेम काम अलग तरीके से करना पड़ेगा।
Okay, thank you, sir. That's so. This is the final question which we have today for our session, and now we will be concluding the session with the vote of thanks. So, I deem it a great honor to propose the vote of thanks to all those who have helped us in making this session such a memorable experience. I, Dr. Rasa Sharma, on behalf of EC Department, GL Bajaj, extend a hearty vote of thanks to our Chief Guest of the day, Dr. Satyakesh Dubey, for gracing today's session. Thank you, sir, for taking out valuable time from your busy schedule and delivering such an insightful and thought-provoking session. We have really enjoyed this complete session, and we have learned a lot of practical insights in 5G and MIMO systems. I would like to also express a profound gratitude to HOD sir and Director sir for their continuous moral support and guidance. I would also thank the coordinators and the Department of ECE for being such a great team and providing us support throughout these 5 days. Finally, the wonderful participants for your unwavering attention throughout the session. Thank you so much for your cooperation. And today, as it's being the last date, so please attend our next session, which is at 2:30 p.m. And the attendance link and feedback form will be shared in afternoon sessions. So please fill it. And we hope that we will be doing such kind of programs, and we will be receiving participation from your side. So thank you all. Thank you, sir. Thank you for today.
Thank you, sir. Thank you very much, sir.
Thank you, GL Bajaj, to give me opportunity to present.
Thank you, sir. We are thankful, sir. आप मत बोलिए, हम बहुत थैंकफुल हैं आपके सर, आभारी कि आप इतने भी अच्छे